Good evening, everyone. Thank you very much for joining in the class. So, what we discussed in our last class? Can anyone tell me what we discussed in our last class?
Sir, about reaction order, sir.
Sorry?
Reaction order, sir.
Okay, reaction order, great. And also the factors, right?
Yes, sir.
Okay. Have you gone through the lectures?
Ji, sir.
Okay, great. You're seeing the screen, right?
Yes, sir.
Okay, so we already know how to calculate reaction rate, right? We already discussed this equation, right?
Yes, sir.
And from here, how can we determine reaction kinetics, right? Whether it is first order, second order, or third order, right?
Yes, sir.
Okay, so if a reaction is zero order in terms of reactant A, what will be the power of M?
Per second, sir.
Sorry?
Oh, sir, sorry.
If the
Per mole.
power?
Per mole per liter, sir.
No, my point is if the reaction is zero order in terms of reactant A, what will be the power of M here? That we discussed in our last class, right?
Zero, sir.
Zero. Zero or one or two or three? Anyone? My point is if the reaction is zero order in terms of reactant A, what will be the power of M here?
Sir, zero.
Zero, right?
Ji, sir.
Okay, zero. And if it is like second order in terms of reactant B, then the power of N is equal to
Two, sir.
2. Great. So today we'll discuss about differential versus integrated rate laws. Okay. So what is differential rate law? Differential rate law expresses the rate of a reaction as a function of a change of concentration. When one or more reactant like convert over a particular period of time. Is it clear?
Ji, sir.
Okay, and what is integrated rate law? Okay, integrated rate law expresses a rate as a function of initial concentration and a measured concentration, like actual concentration of one or more reactant after a specific amount of time. Okay. So we already know about calculus, right? Integration, differentiation.
Yes, sir.
Okay, so today we'll discuss in detail like how we can calculate integrated rate laws and like using calculus, okay, for different reaction order like zero order, first order, second order, third order, like this. Is it clear?
Yes, yes, sir.
Okay, so for the rate we already know that the rate of a reaction is concentration change over time, right?
Yes, sir.
Okay, so if we put equal sign, then we have to use a constant, right? The rate constant K. And for the first order reaction, the concentration to the power 0, right?
G.
Okay, so when we put 0 here, that means anything to the power 0 means 1, right?
Yes, sir.
Okay, then it ultimately become 1. Is it clear?
Yes, sir.
Okay, so then what we get? The rate equals to K, right?
Yes, sir.
Okay, and if we put this dt into here, then we get equation like this, right? And multiplying two sides by -1. Is it clear?
Yes, sir.
Okay, and if we integrate now from like time 0 to time t, like any point, and how the concentration change from initial concentration to that concentration, like at any time t, the concentration is A, then we have to use the integration formula. Is it clear? So why the variable is out here? Because there is no integration for variable. Is it clear?
Yes, sir.
Okay. So there is a general formula, like if we integrate dx, then we will get x. So if we put here dt, then what we will get here?
T, sir.
T, right? Okay. If we put here d here like a bus, then what we will get here?
Bus, sir.
Bus. If we put truck, then we will get here truck, like that. And when we get this value, this limit then becomes issue. Okay. So then we put the limit. Is it clear? So if we integrate this one like dA and here dt, then we will get here A and here T, right?
Yes, sir.
Okay, then we have to put the limit. So we have to put limit like this one. And if we convert this limit, it will become A minus A naught. Okay. Upper limit minus lower limit. Is it clear? For T here as well, upper limit minus lower limit. Up to this point, it's clear, right? Is there any confusion to anyone?
No, sir.
Okay, and for the initial cases, we know T naught. T naught means when the time hasn't started yet, right? So it's zero time, right? Isn't it?
Right, sir.
Okay, so T naught means time zero when the reaction hasn't started yet. So then we can put zero value here. So if we put zero value here, T minus zero means ultimately T, right? And then if we multiply it by K, then we get KT, right?
Yes.
Okay, then if we put this concentration, A naught initial concentration, then we can put it here, right? If we take this side here and a positive sign, is it clear? Is it clear or not? Anyone
Yes,
have
sir.
any confusion?
No, sir.
Okay, then we already know about the equation y is equal to mx plus b or c that we express. Do you know this equation? Y is equal to mx plus b?
Yes, sir. Straight line equation.
Yes, straight line equation. So in the geometry, we use this equation, right?
Yes, sir.
Okay, then we can compare this equation with this one. Okay, so here a equals to y and minus k equals to m and t equals to here x, right?
Yes, sir.
Okay, and here a naught equals to b because we already know the concentration, the initial concentration, right?
Yes, sir.
So the value is known to us. Okay.
Assalamu alaikum, sir.
Yes. Alaikum assalam.
Sir, one of my friend is trying to connect for past 10 minutes, sir.
Oh, okay. Sorry for that. I hope you join now, right?
Okay, sir.
Okay. Thank you. Okay. So if we put the value in a diagram, like in a graph, then we'll get a equation like this, a line like this. Okay. If we put this concentration versus time, then we'll get a line like this. Okay.
Yes, sir.
Okay. So here is the intercept. This b means intercept in y-axis. Is it clear?
Yes, sir.
Okay, so from this, so what does m means? M means slope, right?
Yes, sir.
Okay, so from this equation, we can calculate different maths of zero order reaction. Is it clear? So can anyone explain this equation from the beginning to end? Anyone? So it will be helpful for new persons who join right now. If you face difficulties, I will help, no problem at all, okay? Anyone? Okay, if not, then I will explain it again, no problem. Did you understand it or not? Anyone?
Understood, sir.
Could you kindly explain it again?
Okay, sure. So for rate, we know that the concentration changes over time, right? So the concentration of the reactant decrease over a period of time. That is reaction rate, right?
Yes.
And as the concentration of the reactant decrease over time, that's why we put here a minus sign, okay?
Hmm.
And we all know that the rate of the reaction is proportional to the concentration, right?
Yes, sir.
So when we withdraw this proportional, then we use a equal sign and put a value of constant. Okay. So here k is the constant. Is it clear?
Yes, it is. Okay.
Okay. So if we consider a zero order reaction, then we know that the reaction changes with the concentration to the power zero. That's why it's zero order reaction, right? So when something to the power zero, then it means one, right?
Yes,
So
sir.
for the zero order reaction, we get an equation like this. Change of the concentration equals to constant. And then we can rearrange this equation we have bring this one dt into this side, right hand side, then we can write it something like this. And then we put in, then we multiply both the side into negative 1. Okay, then what we get, dA equals to minus k dt, right?
Yes, sir.
Okay, so when we integrate the change of the reactant with a period of time from initial time to at any point, like at any time period. So then we can integrate it from t0 to t. T may be any time, okay, like 2 minutes, 5 minutes, like that. And at that time, the concentration will be A, and at 0 time, the initial concentration is A naught, okay. So for the integration, there is a formula. If we integrate dx, then we get x. So if we integrate t, what we'll get? If we integrate dx, what we'll get?
X.
Okay, so if we integrate dt here instead of dx, then
T. We will get T.
we will get t. Okay, so after the integration, here there is no limit. So when we put the limit here, like here x naught, here x, so this limit will be come into account. Okay. For instance, here you can see the limit. Here you can see the limit as well. Okay. So with this value, you will put upper limit and lower limit. Okay. Is it clear?
Yes, sir.
Okay, then based on the formula, if we put the limit here, the upper limit will be minus from the lower limit. And here as well, the upper limit will be minus from lower limit. And for the initial time, T naught means at 0 time, okay, when the time hasn't started. So that's why T naught equals to 0. Is it clear? So if we put T naught equals to 0, then we can get something A minus A naught equals to KT, right? Minus KT. Okay, then if we rearrange this equation, we can get something like this. We are just putting A naught into here, this side. So now we can compare this equation with y is equal to mx plus b. So how can we compare this one with y is equal to mx plus b? We can compare concentration of A equals to y, m equals to minus k, and x equals to t, and A naught equals to b. So the initial concentration we already know about the value, right? When you react something, you calculate the concentration, right? Like you can react with 5 mole per liter sodium chloride with 5 mole per liter calcium hydroxide, like this. So the initial concentration you know, right? So
Yes,
this
sir.
is constant. And if we put these values into a graph, then we'll get a line like this. Is it clear? So say here like a concentration, initial concentration is A naught when the time is 0. So here the time is 0. And at time like here, say at 1 minute, you get concentration like A, this here, like this. So the concentration will be decreased continuously like that. Is it clear? Okay, I am taking a 5 minutes break for the azan, and then I will start the class again. Okay.
Okay, sir.
Are you hearing me or not?
Yes, sir.
Okay, so Fardin, can you explain this integrated rate law for zero order reaction?
Yes, sir. So first of all, as we can see that this is because this is zero order reaction equal to zero, we say that minus dA by dt equal to k a to the power 0. And if we want to integrate it over t, then by multiplying with minus, we can get that um, d minus k. First of all, in the left side, we get from concentration c naught to c, Tc equal to minus k t naught to t dt. Then after the simple of integration, we get c minus c naught equal to minus k del t, or t minus t naught. And after that, by evaluating it with the linear equation, we of y equal to mx plus z, we get c equal to minus kt plus c naught. Here I have used c as concentration rather than a, sir. Thank you.
Okay, great. Thank you very much. So can a new person explain this equation now? Anyone? A new person? Adnan, are you hearing me?
Yes, sir. I'm hearing you.
Okay, so could you please explain this equation?
Uh,
The
so should
integrated
I,
rate law for zero order reaction?
uh, sir, should I explain the whole part or just integration part?
The whole part from start to end.
Okay, so basically, the rate for zero to reaction is minus of dt equal to, and it's equal to, sir.
Yes.
Okay, no, it's fine, and it's equal to k, which is the rate constant of reactions, and after we will use a technique which is called separated variables of differentiation, uh, and and after that we integrate the both sides from a naught to a, which is a naught is the lower limit and a is the upper limit, and after integrating that we find minus k, uh, and there the limits have been changed, so the lower limit comes t naught and the upper limit comes t, and after integrating dt we find t. So after we substitute the values of the limit, we find minus k, and here is the upper limit is t, and after doing the integration, when we substitute the values of the limit, we find t minus t naught, and ultimately the value of a comes minus kt uh, plus k t naught, which is basically our a of a naught, and this reaction looks like y equal to mx plus b, which is a which is the equation of a straight line that does not go through the origin.
Okay, great. Thank you very much. So could you please tell me why here is zero? The concentration to the power zero?
Sir, because it's zeroth order reaction.
Okay, zero order reaction, great. And so why we can put here the value of zero for T naught?
Sir, because it's starting from 0th second.
Yes, so when the time initially starts, that means the time hasn't begun actually. So it's time
Yes,
zero, right?
yes, sir.
Okay, great. So thank you very much. Can a new person explain it now? Anyone new? Oporajita Bose, are you hearing me? Oporajita? Arav, are you hearing me?
Yes, sir.
Okay, so could you please explain this equation?
Okay. So zeroth order reactions are basically uh, where the rate does not vary with the increase or decrease of concentration of the reaction. So
Great.
here we are seeing that the rate of the zeroth order reactions is defined by d by a by dt, which we call as a constant, which is k. So then we replace the rate constant. So that comes at dA equals to k minus k dt. So after that, as it is a zeroth order reaction, so which means from the initial concentration to the sir, what does the A naught to A means? Could you please state? Yeah?
So initial concentration is A naught, like when the reaction hasn't
Mhm.
started, okay, at time 0.
At time
And
zero.
at time t, at any time point, the concentration is A. Is it clear?
Yeah, 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 yeah.
Okay, great.
So the limit has been set, and sir, I do not know the right terms of it. I just forgot.
Okay, so if we integrate dx, then we get x. Okay.
Okay. So the integration is, if we integrate ds, if we got x, then as by setting the limits from a naught to a, we get minus kt t by t naught. So at the last part, so the equation can take form like this: a equals to minus kt plus a naught. Could you please lower your screen? This is the last part. Yes, thank you. So the equation looks like the y equals to mx plus b, where we replace y with a, and the rate constant minus k is replaced with m. So and the x equal by t, and b equals to a naught. So that's how I plot it in the graph and everything.
Okay, so m is the slope, right?
M is the slope. Yes.
Okay, great. So the slope will be minus k, right?
Yes.
Okay. Thank you very much.
Okay. Thank you, sir.
Okay, so what will happen for the first order reaction then? So here the concentration will be to the power 1, right?
Yes, sir.
So So for
Okay.
the zeroth order reaction, the concentration of the reactant was not dependent, but in, I
Yes.
think, first order reaction, the the concentration of the reactant will be dependent on the reaction rate.
Yes, great. So for the first order reaction, we know that the reaction will be changed, the concentration to the power 1, right?
Yes, sir.
Okay, so if we put the value 1, that means we get just concentration, right? Is it
Yes, sir.
clear?
Clear, sir.
Okay, so and if we reorganize this equation, we will get something like this, right? Is it clear?
Yes, sir.
Okay, so there is a formula. If we integrate 1 by x dx, then we will get ln x. And this one we've already discussed, right?
Yes, sir.
Okay, so what will be the value if we integrate d concentration a by a?
One by s.
We can express it like 1 by a dA, right?
Yes, sir. Ln and then.
Okay, so what will be the ultimate value? Ln a, right?
Yes, sir.
Okay, ln a, and then we'll put the limit, right? Lower limit, upper limit, like the previous equation. And for the t, here the time is same like the previous equation, right? 0 to any time point t. So then what we'll get ultimately? We'll get ln a minus ln a naught, right? Equals to minus k into t minus t naught. For the initial time, the time is 0. So here we'll put 0. Then we'll get ln a minus ln a naught equals to minus kt, right? and then if we reorganize this equation, we can put ln here. So here there will be a plus sign, right? And then we can compare this equation as well, y is equal to mx plus b. Is it clear up to this point?
Yes, sir.
Okay, so if we put this value into a graph, we'll get a line like this one. So as the concentration of the A we know, the initial concentration A naught, then if we ln it, the value we also know. So that's why it's constant, right? Is it clear?
Yes, sir.
Okay, so can anyone explain now the integrated rate law for the first order reaction? Akhtar Nur Muhammad.
Yes, sir.
So could you please explain this one, the integrated rate law for the first order reaction?
Yes, sir. First, we know that it's a first order reaction, so this time power A will be 1. So we get A. So after rearranging, we get dA by A equals to kT, where K is the concentration constant. Now we integrate both sides and put the limits, and after integrating both sides, we get ln A from the left side, and from the right side, we get kT. The lower limit is T naught and T. And after putting the limits, we get this ln A minus ln A naught, K minus T naught. Here T naught is simply 0, we put the values, and then finally we get ln A equals to minus KT plus ln A naught. Here we compare this formula with the straight line equation, and here we get m, which is slope, equals to minus k, and b equals to ln A naught, and y equals to ln A.
Okay, thank you very much.
So
Okay,
এটা তো
so
এটা তো a equal to a naught e to the power minus kt দিয়েও লেখা যায় স্যার।
yes, we can write it like this.
আচ্ছা,
So if we
লং
convert ln into equation, okay, so we can also prove this equation for second order reaction, right? Is it possible to prove or not?
Yes, sir, it's possible.
Okay, so for the second order reaction, what will be the power here?
2. For a's power will be 2.
Okay, 2. Then,
And then we'll just integrate just like the previous part, and this time we'll get aq divided by 3.
sorry.
No, sir, this time after rearranging, we will integrate it, and after integrating by putting the formula, we'll get something like this.
Okay,
Over here.
so here there is power, right?
Yes, there's a power 3.
Here power 3 or 2 here?
2, sir, 2. And if we integrate this, we'll get something like this, shown in the formulas.
Okay, according to the formula, we will get the value, right?
Yes, sir.
Okay, so if we integrate this one, what we will get?
1 by a, sir.
Sorry?
1 by 1 by a.
Okay, 1 by a. So how we got 1 by a?
So n into x to the power n plus 1, sir. That law. Here n equal to
Okay.
minus 1. Sorry, minus 2, sir. Minus 2, sir. And then we just add
So
it
here
with
it will be
1.
minus 2, right?
Yes, sir.
So minus 2 plus 1, right? So it will be minus 1, right? X to the power minus 1, right?
Yes, sir.
Is it clear to all?
Yes, sir.
Okay, then if we put the limit, we'll get something like this, right?
Yes, sir.
Okay, now if we reorganize this equation, we can put the initial concentration here and this into here, right? And this one we can take this side. So what we can get ultimately, 1 by concentration A equals to Kt plus 1 by N0, right?
Yes, sir.
Okay, so what will be the value of Y here?
1 by A, sir.
Okay, and B will be?
B will be 1 by A naught.
Okay, great. And M?
M is slope, so slope will be K.
Okay, slope is K. So it is positive K, right?
Yes, it is increasing.
Okay, so the slope will increase, okay? So can a new person explain the second order reaction for integrated rate law? How can we get equation? A new person? Farabi Fardin Khan, are you hearing me? Farabi?
Just Assalamualaikum, sir.
Walaikum assalam. So could you please explain this reaction? Integrated rate law for second order reaction.
I'm sorry, sir. I missed the last part a bit. So
Okay, so up to which point you can explain?
I'll have to take a look, sir. I
Okay, you have
just
to take a
went
look. Okay.
for a
So
bit.
okay, who can explain it? Zarin Tasnim, are you hearing me?
Yes, sir.
So could you please explain this?
Sir, here we will find the second order reaction where n is 2, and so we have to find rate for it where we will put n is equals to 2 in k of a. So we will find like this, integrating it.
Okay, so how you will integrate now?
Um, we will integrate we have this into uh, x to the power n dx. We have this formula, so we'll put on the uh, en integrated, and thus we get. Sir, I have a little confusion in this.
Okay, where you are confused?
Sir, we have to basically find the second order reaction where n is equals to 2, right? So we will put in the rate and we will find.
So we have put here 2, right?
Yes, sir.
Okay, then we just reorganize it. We have put it here, right?
Yes.
Okay, then we integrate it. So from when the time is 0, the concentration is A, not. And when the time is T, the concentration is A, okay?
Yes, sir.
And when we integrate it, then there is a formula, okay? So x to the power n dx equals to
X to the power n
x
plus 1.
n plus 1 into
N
n
plus
plus
1.
1. Is it clear?
Yes, sir.
Okay, so here the n power equals to minus 2, right?
Yes, sir.
Because
Minus 2.
why minus 2? Because it is already it's divided by form, right? So if we put this one here, then we have to put a minus sign, right?
Yes, sir.
So there will be concentration A minus 2, right?
Yes, sir.
Okay, then here will be minus 2 plus 1, and here will be minus 2 plus 1, like that. Is it clear?
Yes, sir. So we get x squared
Okay,
dx.
so then the minus 2 and plus 1 will be,
Minus 1, minus 1.
okay, here will be minus 1 and here will be minus 1 as well, right? So if we multiply this one with minus 1, then we'll get minus x to the power minus 1, right? That
Yes.
means minus 1 by x, right? Right?
Yes, sir.
So here we get something like this then. And then we'll put the limit. Is it clear?
Yes, sir.
Sir, can I ask you a question?
Yeah, sure.
X to the power n plus 1, then isn't it divided by n plus 1 in the formulas? X to the power n dx.
X to the power n dx. So what is the problem here?
Isn't n by 1 divide x to the power n plus 1 divided by n plus 1? Isn't it the formula?
X to the power n dx equals to
X to the power
x to
n
the
plus
power
1
n plus 1 into n
divided
plus
by
1.
n minus 1, n plus 1.
It will be divided by n plus 1.
Yes, sir.
So far I know it will be n plus 1.
Okay, sir.
Assalamu alaikum, sir.
Yes.
Sir, there is a load shedding in my area. I have to go to a store and recharge my phone and buy data.
Okay, great. So
Sir, can
you
you?
can leave, no problem. Just put your name and ID and you can leave.
Oh, okay. Thank you, sir. Thank you so
Sir,
much.
sir,
Assalamu alaikum, sir.
I have a quiz. Can I also give?
Yeah, sure, you can leave, no problem.
Thank you, sir.
Okay, so then we put the limit, right?
Yes,
Sir,
sir.
স্যার x to the power n plus 1 by n plus 1 ই তো হওয়ার কথা স্যার। ইন্টিগ্রেশন ল তো তাই বলছে স্যার। Sir, I have just checked now, and yes, it is divided by n plus 1.
Okay, divided by n plus 1.
Yes, sir.
Okay. Okay, so ultimately the value is same, right? Because if we divide it by n plus 1, then it will be minus, right? Ultimately minus 1, right?
Yes, sir.
Okay, so we get minus 1 by a, right?
Yes, sir. Now it makes sense.
Okay, great. So now we will put the limit, right?
Yes, sir.
And when we put the limit, and after putting the limit, we'll rearrange the equation and we'll get something like this, and we can compare it with y is equal to mx plus b, right?
Yes, sir.
Okay, so then if we put this equation into the graph, then we'll get a line like this. Is it clear? So what will be the initial concentration here in this graph?
So 1 by n, sir.
Okay, and the slope will be?
K, sir.
Okay, great. So now if we start from here, so at the half time, like when the concentration will be half, right? The 50% concentration at a time.
Yes, sir.
Okay, so when the concentration will be half, then we put N naught equals to half, right?
Yes, sir.
Okay, so A will be converted to A naught, right? Half of A naught, right?
Yes, sir.
Okay, so then half-life, we can rearrange this equation. We can get the half-life for the zero order reaction, initial concentration divided by 2K. Is it clear?
No, sir, I didn't understand half-life.
Okay, great. So for the zero order reaction, we got the equation like this, right?
Yes.
Okay, so with the time, the reactant concentration will decrease, right?
Yes, sir.
So say here like there is like 100 mole of reactant A, okay, at the initial time. So initial concentration is 100 mole, okay. So after a certain time, the concentration of the anode will decrease, right? With the time being, because the reactant will be converted into product, right?
Yes, sir.
Okay. So when it become 50%, we consider the time is T half, okay. The time at which the reactant concentration become 50%. Is it clear?
Yes, sir.
Okay, so the concentration of the A will be half of A naught, right? Is it clear?
Yes, sir.
Like 50%. So if it is 100, here it will be 50. So if we divide 100 by 2, we'll get 50, right?
Yes, sir.
Okay, so here we can put here 2, and then we can like if we half it, then we can get the A, right? At T half. Is it clear?
Yes, sir.
Okay, so for A, we put it here A naught half. And then if we reorganize this equation, we'll get the value of T half equals to A to the power 0 divided by 2K. Is it clear?
Yes, sir. It's clear now.
Okay, thank you very much. So it's same for other equation as well. Like if we put here the time T half, T equals to T half, then we'll get A equals to A naught half, right? Is it clear? So for this equation, we can replace A by A naught half, right?
Yes, sir.
Is it clear or not?
Yes, sir.
Okay, so and then if we reorganize the equation, we can get something like this ultimately. Okay. And for the second order reaction, the same value as well. Like for the A, it will be half, right? So in that equation, we'll just put for A, we'll put here half A naught like this. And if we rearrange this equation, we'll get T half equals to 1 by K into A naught. Is it clear?
Yes, sir.
Okay, so if in any math, the value of like T of is given and the constant is given, so then we can calculate the concentration of A naught, right?
Yes, sir.
Okay, and if the concentration of A naught is given and the K value is given, we can also calculate the T half, right?
Yes, sir.
Okay. So do you have any confusion regarding the equations? Anyone? Thought we have explained? Okay, if not, then I hope you will prepare well this lecture, and then in our next lecture, we'll solve some maths. Is it clear?
Yes, sir.
Okay, so those who have attended, could you please type your name and ID in the chat box for the attendance? So you already know the time of the quiz one, right? Time and syllabus.
Yes, sir.
Okay, so I wish good luck for you and prepare well for the quiz one. And please submit your assignment on time. Okay. Do you have any question or query regarding assignment or quiz?
No, sir, thank you.
Anyone?
No, sir, I think we are good for today.
Okay, thank you very much. So I am closing this session for today. We'll see you in the next class. Meanwhile, stay safe. Allah Hafiz.
Assalamualaikum, sir.
Have a nice
Assalamualaikum,
Assalamu
sir.
alaikum, sir.
Assalamualaikum, sir.
day.